Very important application of vector, which is inequality. And mostly in the last 10 years of J advanced problem or even J mains, they have resorted to just two inequality. There is no direct inequality in the syllabus of J advanced. So obviously they will not ask anything apart from this. Now the reason behind CS inequality can be asked indirectly is that this inequality can be connected with the ideas of planes or lines or conics, which I will discuss today. So there is a huge geometrical correlation between Cauchy Swartz inequality and the idea of planes, lines, conic and vector algebra vectors. So because of the reason these are in the syllabus of J advanced, so they can easily connect this with geometrical perspective, this inequality. The other obvious inequality is AMGM, and apart from this, AMGM basically the other obvious inequality is AMGM, which basically you are using in the chapter sequence and series. There is a bypass method for AMGM inequality, which is calculus. So apart from this, all the inequality can be easily done with calculus as far as JEE questions are concerned. I'll not go into like the unnecessary rituals of the inequality, rather will directly hit the bullseye. And here we go. Let's say we have two vectors. Cos theta is definitely lying between -1 to 1. Hence mod of u dot b will be mod of magnitude of u, magnitude of b, cos theta. And this quantity is mod of u to mod of v into mod of cos theta. And since mod of cos theta is always less than equals 1, hence this quantity will be less than the magnitude of u into magnitude of v. So simple, so elegant. So we have u dot b for any two vectors, the mod magnitude of u vector. So you have u dot v is less than equal to magnitude of u vector into magnitude of b vector. So this is a basic and fundamental form of Cauchy Swartz inequality. Now of course let's see under what condition we'll get the equality case. Okay, so of course for equality case cos theta mod must be 1. So cos theta should be plus minus 1. So theta will be 0, pi, 2 pi, 3 pi and so on. Okay, now for vector world, of course theta equals 0 means both vectors is in the same direction. What is the meaning of vectors in same direction? So if you have got u and b, they have same directions. If it is pi, so they are in opposite direction. If it is 2 pi, again it is in same direction. 3 pi opposite directions. So if they are in same direction, I can write u is lambda times of b. If they are in opposite direction, still I can write u is lambda times of b. But lambda will be positive if it is in same direction, lambda is negative if it is opposite direction. So hence for the equality case of Cauchy Swartz inequality, we must have u equals lambda times b. It means let's say u vector is having component u1, u2, u3. Okay, which means like u vector in 3D is u1 I cap plus u2 j cap plus u3 k cap. And let's say v vector is having component v1, v2, v3. v1 I cap plus v2 j cap plus v3 k cap. Since they are parallel or anti-parallel, hence the ratio of the coefficient will be same. So u1 by v1 equals u2 by v2 equals u2 u3 v3. Okay, so this is the equality case of this inequality. Now just with these two basic information, we can solve almost all JEE problems or the related problem even in vectors in 3D. Now is there any other version of this Cauchy Swartz? It's not exactly known as Cauchy Swartz inequality, hence I have given a star. But what about cross product of two vectors u cross b? We know it will definitely have vectors magnitude of u into magnitude of b into sine of angle between them. So this quantity is a scalar, and given any two vectors, we can always create a dimensions 2D plane. And if 2D plane exists in the world, the next immediate question was, where is the observer who is watching this plane? Of course, you cannot be the part of the plane because then you can't see the entire plane. So observer must be out of the plane. And hence, this is a philosophical region of defining something beyond this world of two vectors, and it's a way of creating 3 dimension out of 2 dimension, right? So we define u cross b is a vector with magnitude uv sine theta and its direction along perpendicular to u and b. So let's call it nk. Since this thing is known to you, and I'll have a separate lecture on the essence and problem solving on cross and dot product. Right now I'm particularly focusing on G advanced. So the essence and the beauty will definitely be not sacrificed, but once J is over. So again, you can see if u cross b magnitude will be less than equals this time, you can use theta. So basically we have this is an equivalent version. Here again, for equality case, what we'll be having? For equality case, sine theta should be 1, right? It means theta should be 90. So u cross b, let's say if you have a vector 2y and we have got a vector 3j. Okay, so these two vectors cross product will be 6k. So clearly 2y cross 3j magnitude same as the magnitude of 6k. So this equality case happened because this magnitude into this magnitude, exactly this magnitude, 3 into 2 equals 6 in terms of magnitude. This happened because angle is 90 degrees. Okay, so keeping these things in mind, we are ready to hit the bullseye. And here we go with the first problem. The first question is, find the range of 2 sine theta plus 3 cos theta. Of course, theta belongs to real. So now the point is, can you apply this vector concept to solve this problem? It feels really crazy. Of course, one way of doing this will be you write this in terms of r cos some golu plus theta in polar format. In fact, it can be done. The other way will be simply you differentiate and use calculus. The other format will be maybe someone will keep it as x equals something and probably x minus 3 cos theta plus 2 sine theta, then he'll square it. Sine square theta I can convert into cos theta. So now basically I'm getting a quadratic in terms of something x plus something. Of course this involves theta. Now if x is real, this quadratic must keep a real root, d get n equal to 0. So now we'll get a quadratic which is x square plus 9 cos square theta minus 6x cos theta equals 4 into 1 minus cos square theta. Of course I'll not do this calculation because these are the alternative method of doing this. And you know this is a quadratic in cos theta, so cos square theta plus something cos theta plus something else equals 0, and that will involve x, right? So since cos theta is real, so d get n equal to 0 will give a condition. Moreover, cos theta is also limited to minus 1 to 1. So the roots of this quadratic must be limited to minus 1 to 1, as well as d must get n equal to 0. So from there, using basic quadratic also, you can find the range of this. But what we are going to do here is a surprisingly beautiful way of tackling this. And let's see the vector approach. So again, 2, 3, I can think of a fixed vector, a vector, which is 2y plus 3j. The motivation is clearly because 2 sine theta plus 3 cos theta was feeling like as if someone has taken dot product of 2, 3 with sine theta cos theta, right? And let's say take another vector, b vector equals sine theta I plus cos theta j. Now using dot product, we know a dot b will be less than equal to ab. Just now we have proved this, and the question is done because a dot b is 2 sine theta plus 3 cos theta, and mod of that magnitude is less than mod a. Magnitude of first is root 13, and magnitude of this is root 1, which is just 1. Okay, hence what's the answer for this? 2 sin theta plus 3 cos theta will dance from minus root 13 to plus root 13. And all of you know this formula basically, like the mod will go from root over a square plus b square to minus root over a square plus b square. This is proved by so many methods. Now the beauty is at what point the inequality will come. Now the beauty is at what point equality will come. So I have already discussed equality will come when a and b will be parallel. It means the ratio of coefficient will be same. Hence 2y sin theta will be 3y cos theta. So for equality, tan theta should be 2 by 3. So you know the full information of this. So we know maximum value, minimum value, hence inequality. This was a simple problem. Let's move to the next challenge. Let's say you have x plus y plus g equals 1. Of course, x, y, g is real, right? X, y, g is real. So I'm discussing all these problems for real number. I'm not writing anything. We have to find the minimum value of this expression. Now, how we can use x, y, g information with x square, y square, z square. Again, it gives a feel like if I think of xi plus yj plus zk as a vector, it has some relation with this because this represents magnitude of that. So let's call this again, let me call a vector as this. So we know mod a will be x square plus y square plus z square. Now we want b vector to be something, right, which is unknown, such that a dot b becomes the given condition. Okay, so can you guess it? It's quite easy because with x nothing is there, so I can treat the coefficient as 1 1 1, and that gives a hint of taking b vector as 1i cap plus j cap plus k cap. That gives a hint of taking b vector as I plus j plus k. Now simply apply a dot b. I will choose this mod a mod b, and we are done. A dot b gives you x plus y plus z magnitude. Mod a is root over what is being asked, and mod b is root 3. Now this quantity is already 1. So root over x square plus y square plus z square will be greater than or equal to 1 by root 3. Hence after squaring, this answer is 1 by 3. You can also find the value at which minimum will be achieved. At what value it will be achieved? When these two vectors will be collinear. So a will be lambda times of b, which gives the ratio of coefficient x by y, z by 1 to be same. So equality will be achieved when x equals y equals z equals 1 by 3. I hope you have enjoyed this method. Although it's basic, I'll go to more involved problems. But there is something more to this question. See, JE can put this problem even in the planes and 3-dimensional applications. If we look closely, so second solution, what does x plus y plus z equals 1 represents? So it's basically a plane, right? In R3, in 3D world. And what does x square plus y square plus z square represents? In fact, it's a square of distance of a point from origin, right? So this is distance of x, y, g from 0, 0, 0, and that is square. So there is a nice geometrical meaning of this. So it means as you are walking on this plane anywhere, as x, y, z is lying on the plane, what is the minimum distance of origin from a random point on the plane? So of course minimum distance will be the perpendicular distance, right? And you know the formula for perpendicular distance directly, which you can derive very easily. So that will be distance will be root 3. So that directly gives you the answer. It's a square 1 by root 3 square equals 1 by 3. Not only this, you also know the point along minimum distance, because for x plus y plus z, the normal vector is in the direction of 1 1 1. I'm using shorthand notation 1 1 1 4 I cap, j cap, and k cap. So we know the minimum distance will be along this direction 1 1 1. Okay, so that directly gives me a point also, because any point on this line. So this line is passing through 0 0 0 in the direction of 1 1 1. So any parametric point will be 0 plus 1 1 1 times t, right? 0 0 0. All of you know the basic parametric form because it's advanced revision class. So any pearl on this string is in the fashion of t comma t comma t. Now if this pearl is a member of plane society, so t plus t plus t must satisfy this. So t equals 1 3, and that gives you the answer. Even for the point, 1 by 3, 1 by 3, 1 by 3. This one also gives you visualization for the maximum distance. So what is maximum distance? Yeah, clearly it's infinity, because plane extends equally in all directions. That makes sense, because x you can take 10 trillion, y 20 trillion, and z will be minus 30 trillion plus 1. Okay, so its square is anyway going to be very large. Now this question can be more interesting if there is some restrictions on further xy, right? Because when xy is restricted, the z will be restricted. So under that restriction, the maximum distance will come on the corner. That can be still be a good way of preparing the question. I'm sorry from my handwriting, because I always get like deeply involved in the concepts rather than. I hope all of you are enjoying the video. Let's move to the third question. And here we have 2x plus 3y plus 4z equals 1. Now we need to find x square. 4 y square by 9 plus z square by 16. Unfortunately, the still first expression represents. Unfortunately, still first represents plane, but now no more. This represents distance from origin, right? So this time is not this distance. So you have two ways. Either you like manipulate this as distance from origin, or you have to do something else. So of course, can you give a geometrical solution? Take a pause and think over this. Okay, so yes, there can be a geometrical solution, because first expression can be written as x by 2 whole square, second is y by 3 whole square, and third is z by 4 whole square. And now I can treat x by 2 as capital X, y by 3 as capital Y, and z by 4 as capital Z. So the question is fundamentally same as before question. So we want to minimize x square plus y square plus z square under the restriction of, now what is x? X by 2 equals capital X, a small x is 2x, a small y is 3y, and a small z is 4 capital Z. So accordingly, the guardianship on the question gets converted to 4x plus 9y plus 16z equals 1. So under this restriction, 4x plus 9y plus 16z equals 1, we have to find the minimum value of this. So we have a new plane now in the new world. Basically what I have done is scaled down the problem. Okay, so you should not worry about how it's scaled down and how transformation is done. Basically I have transformed this, and it can also be those who know matrix. This is kind of linear transformation. Anyway, so I'll not talk about those crazy words. So 4x plus 9y plus 16z equals 1, and x square plus y square z square. So of course here minimum value will be again distance from origin. So answer will directly be 1 by root over 16 plus 9 square, 81, and plus 16 square, and whatever it comes, that will give you that. If you want to find the point, you can, once you know x, y, z, in this new world, along these directions, again normal direction will come, and you can bring it back to the original world. But of course, we have an elegant solution for this, the format of Cauchy Swartz. So directly how to apply Cauchy Swartz? So 2x plus 3y plus 4z equals 1, and now we have x square by 4 plus y square by 9 plus z square by 16. Now we know by looking at these expressions, it will be generated out of x by 2 whole square, right? So clearly x square, y square, z square is available in the picture, but we need to get 1 by 2, right? We need to have 1 by 2, 1 by 3, and 1 by 4 kind of a structure. So how to go about it? Like on which two vector I'll apply so that it will give invitation to these terms. Let's say if someone takes vector A as x, y, z and vector B as 2, 3, 4, which feels an obvious way of selecting these vectors. So their dot product is 1, it's given in the question. But unfortunately, mod of A will be x square plus y square plus z square. So you'll not be able to get this. Okay. So now what's the point? Yes, point is very clear. We have to redefine vector A such that it gives birth to terms like x square by 4, y square by 9, and z square by 6. And that's not very difficult. If I define A, instead of x by z, x by 2, y by 3, and z by 4, and B vector as leftover, because we know how to produce 2x now. So we want x by 2, y by 3, z by 4, dot, Golu, Bholu, Bicky, whatever, should be 2x plus 3y plus 4z. It means x by 2 is already there. So what should be this star, Golu, such that it gives 2x. So you know, like x by 2 into a star equals 2x, x is cancelled, a star must be 4. Okay, so that gives you a thought what to bring there, right? And second must be 9, you can easily check it must be 16. So it's 4, 9, 16. So the other selection of vectors would be 4, 9, 16. Now once you know A, B, directly problem is solved in the same way, because A dot B is mod A to mod B. You can clearly see like 4, 9, 16 was something which was already coming here, right? So method 1, method 2 is definitely correlated. The first method gives you a visual feel of the situation. The second method gives you algebraic feel using vector algebra. Okay. Now you might be feeling very interesting, but at the same time lesser challenging. So let me move to the next question. This time we have ABCD, which is a real number, and we have sum of a squares equals 16, and A plus C plus B, A plus B plus C plus D plus C equals 8. All these guys needless to tell real. We have to find the range of E. We need to find range of E. Okay, so again you can think of the situations like A plus B plus C plus D plus C, and we have A square plus B square plus C square plus C square. Now no more we are in 3D. Basically it's how many dimensions? 5 dimensions. The beauty of Cauchy Swartz inequality is even if vector A is, let's say, A1, A2, A3, A4 till An, and B, at least in terms of mathematical structure, B1, B2, Bn, this can be proved very easily. And still A dot B, this statement will be less than mod of A to mod of B. Now some of you might question here, like what does it basically mean even to define, you know, like 4 dimension in something. And that's the beauty of mathematician. Okay, they basically call it norm, means magnitude of vectors in this. This can be done in a other way, via principle of mathematical inductions, or by taking a quadratic expressions and making d get n equal to 0. So there are many proof, like 10 or 12 proof which I have seen and which I know. And of course, like just because I don't know something, it doesn't mean that it doesn't exist. So there can be many more. Anyway, so I'm not talking about that. So there is a way to solve this problem, okay, using Cauchy Swartz. So this time we want restriction on E. Okay, so E will take a side because that guy is a special. We want is a special treatment, and on the remaining guy we'll apply Cauchy Swartz. So we know A plus B plus C plus D is gonna be 8 minus E, and A square plus B square plus C square plus D square 16 minus E square. Now if I consider 2 vectors, so this time I'll not use the word IJK because next I have to use Golu or something else, right? So if A vector is ABCD and B vector, this time of course you can clearly see it's 1 1 1 1 because ABCD will give birth to A square B square C square D square. So B vector is 1 1 1 1. So applying Cauchy Swartz, we got A dot B mod less than mod A mod B. So this still holds, okay. Although what is the meaning of cos theta here? That feels something really nonsensical. But algebraically what it tells, like if we'll take A into 1 plus B into 1 plus C into 1 plus D into 1, its magnitude will be less than equals A square plus B square plus C square plus D square into 1 square plus 1 square plus 1 square plus 1 square. So at least for 4 dimensions there is nothing called, you know, like cos theta over here, and it's still working. If I'm blindly applying this, so now A dot B, we already know this value 8 minus E whole square is gonna be less than equal to 4 into 16 minus E square. I've just squared both term from here, and that will give a bound for E because E into 5E minus 16 is less than equals 0. Okay, So we have 0 and 16 by 5. So value of e dances from 0 to 16 by 5. Now of course whether these values can be achievable or not, that you can check easily. How? Because for these two vectors, for equality to take place, a must be lambda b. It means a by 1 must be b by 1, must be c by 1, and must be d by 1. So a, b, c, d must be equal. So when they are equal, under that conditions, you can just test for the value of e. And in fact here in this problem, the inequality in both cases will be achievable. And that a little bit you can think by yourself. Now some of you might tell, sir, 4 dimension is not in the JEE syllabus. So this was an irrelevant question. My defense will be very interesting. Since JEE Advanced has already incorporated a statistics, so here are beautiful answers for this. All of you know a plus b plus c plus d, it feels like mean, right? Like sum of numbers, average. And this feels like sum of squares. And you know what is variance? Mean of a square minus square of. Okay. And since variance of any data set, so you apply variance on A, B, C, D. And we know it will be sigma xi y n whole square minus sigma xi whole square y. And since variance is non-negative number, so from there you will get exactly the same inequality. And for variance to be 0, okay, all the numbers should be equal. So mean of a square minus square of. There is another beautiful approach, because some of you might tell, like since 5 dimension is not in the syllabus, so this was not a JEE relevant question. Still JEE Advanced can ask this question and how it will be solved. Well, they have incorporated a statistics in syllabus, and that will be my defense. If I apply mean and variance concept, now why that idea should come? Because by looking at this number, it feels like it's average of some number, right? Of course, like divided by 5 I can take. And that feels like sum of a squares of a number divided by 5. So you're tempted to feel like sum of a squares and mean of a square is square of mean kind of thing. Okay, so variance. And what is variance? It's mean of a square minus square of mean, right? So sigma xi whole square yn minus sigma xi y and whole square. And you know variance for any data set is greater than or equal to 0. So it's non-negative because variance represents the dispersion, right? And hence we are able to define a standard deviation, which is root of variance. So here equality case will give you when all these data set is equal. So by putting the restriction variance greater than or equal to 0, we got the same inequality. In fact, the proof of variance greater than or equal to 0 is coming from Cauchy Swartz. You can apply on sigma xi square and sigma xi by taking other vector as 1 1 1 1. Okay, so I hope you must have enjoyed this. There is yet another approach for this problem, for those who don't know even variance, as well as, you know, like this Cauchy Swartz. Then what he can do is, see, like if I'll put one variable in terms of other, let's say if I keep a in terms of all the other variables, so a will be 8 minus b minus c minus d minus e, blah. In that, okay, so let's say if I keep a in terms of other variables, like a equals 8 minus b minus c minus d minus e, and put it in the first equation. So you get a quadratic in b. Of course, it's a quadratic in c, d, e, every way, but you find a in terms of all other variable, put in the first equation, get a quadratic in b, make d greater than or equal to 0. That will give a restrictions on c, d, e. Again, from that restrictions, you will get a quadratic in c, and that should always be greater than or equal to 0, so upward parabola. So for that, d will be less than or equal to 0. Again, from that restrictions, you put d greater than or equal to 0 or less than or equal to 0. Again, redo it and redo it. And finally, you'll get a restriction on e, right? And because of the symmetricity of the problem, all the variables will be restricted by the same amount. So e was not a special. If I ask you what is the range of a, it will be same as e, right? It will still be 0 to 16 by 5. So by repeated use of quadratic discriminant, this question can also be done without any discrimination. Okay, so there are so many approaches of doing this. Anyway, let's move to the next question. here is a problem. Let's say we have x, y, z. We satisfy two constants, 2x plus y plus 2z equals 9 and 5x plus 5y plus 7z equals 29. So if x, y, z belongs to real number such that it satisfies this and this. Okay. Okay, so let's move to the next question. So question goes like this: let S be the set of all x, y, z belonging to real such that it satisfies this both expression, 2x plus y plus 2z equals 9 and 5x plus 5y plus 7z equals 29. Please note there is a huge difference between and or. When I tell it satisfy this or this, means either you can be on this apartment or this apartment. When I tell you satisfy both of them, then you have to be on both apartment, like on both line or both plane or whatever. So in case of parallel line, there will be no solution. In case of intersections, every point is belonging to both of them. In case of intersections, so when we are talking about n, it means x, y, z should satisfy this as well as this restriction. Now the question is, you have to find x square plus y square plus z square minimum value when x, y, z belongs to set. So this is a standard way of asking question. Give a pause and try to solve the problem. Okay, so here is the solution. We know again we'll decode this geometrically because x square plus y square plus z square is nice to be decoded as a distance from 0, 0 to a random point x, of course its distance is square because distance will be root over that, or it doesn't matter, final answer will have to just square. What about the first equation? First equation, as you can easily see, it's a plane, so let's call it plane number 1. What of the second equation? It's some other plane, so let's call plane 2. So what about all the set of points which is lying on both of the plane? Of course, that represents the line of intersection of these two planes. You can clearly see the directions of the first plane is 2, 1, 2, and direction of second one is 5, 5, 7. Hence these two planes are not parallel, hence they will definitely intersect on a line. Now what is the direction of this line? Let's say this is n1 and n2. So direction of line is nothing but n1 cross n2. Now the question is, we have origin somewhere and we need to find the minimum distance of origin from any random point walking on the line. Of course minimum distance will be the perpendicular distance. Okay, so we are interested in just this spatial distance, OP spatial, and also till the point. So I hope it's very clear now what question means, and our rest is just mechanical calculation. So first we'll calculate n1 cross n2, which is ijk 2, 1, 2, and it's 5, 5, 7, and that gives the value of, for I will get 7 minus 3i minus 4j and 5k, right? So this is I component, j component, k component. Usually in exam you should also write in terms of unordered pair. Sorry, usually in exam you should also write in terms of ordered pair, because ordered triplet or ordered pair, because that saves your time not to write IJK. So we know this line direction, right? It's along minus 3, minus 4 and 5. We have origin somewhere 0, 0, 0. Now if I know just one single point on this, I can find the equation of line, and once I know equation of line, finding the minimum distance will be a routine job, because we'll write independent parametric form, and this over this dot will be 0. Okay, so let's try to find an equation like a point on the line. Let's try to find a point on the line. From 9, it's obviously better to try an integer solutions. So let's say 2 plus 2 plus 1 will be 5. So if x is 2, z is 2, 4 plus 5, 9. Okay. So 2, 1, 2 definitely works for the first. Is it working for the second? 10 plus 14, 24 plus 5. Yeah. Good. So 2, 1, 2 is lying on the both plane. Of course, in general way, you can put z equals 0 and find x and y. Okay. So there are infinitely many points on this line. So your life, your choice. Here I am lucky to directly observe a point 2, 1, 2. Here I am lucky to directly observe a point 2, 1, 2. Okay, so now what will be our treatment? Our treatment will be, I'll take a random point on this line. So what is random point? 2, 1, 2 plus 3 times of direction, right? Because you know, like the difference between these two vectors, so the direction of this vector is along this. If I take any point here x, y, g from the very basic vector side, yeah, I know this vector will be now parallel to this given direction vector. Okay, so x minus 2 by minus 3 should be equal to y minus 1 by minus 4 and z minus 2 equals 5. So from there you'll get any point as this plus d times of this in parametric form. These are extended vectors and 3D notations which you must be. Now I know I'll calculate this vector, which is just this dot this direction minus 3, minus 4 and 5, and we'll make it 0. Once we'll make it 0, we'll get a value of t, and once we'll put the value of t, game is done, because we know the point and things is obvious. I hope you got the approach. Okay, so for this particular problem, there was one very simple observation, because this distance, this direction is minus 3, minus 4, minus 5. And what about this vector? Joining origin to 2, 1, 2 is 2, 1, 2 itself, right? Now what is 2, 1, 2 dot minus 3, minus 4 and 5? That's minus 6, minus 4 plus 10, and which becomes 0. Oh, so it means like the point 2, 1, 2 was exactly on the perpendicular. Okay, hence what is the point corresponding to which minimum distance has occurred? It's 2, 1, 2. So at x equals 2, y equals 1 and z equals 2, we'll get the minimum value of x square plus y square plus z square. And what is the minimum value? It's nothing but this distance, which is 4 plus 4 plus 1, which is root 9, which is 3. But remember, this is not distance. We want a square of distance. So minimum answer will be 9. Clear? Well, so this was quite fanciful questions, which shows you in general how to approach it. Plus 3x minus z whole square plus 2x minus y whole square, maximum value under x, y, z belonging to this set. Now give a try and pause the video. This is still a challenging one, but this time what we have done is we have no linear and quadratic kind of relation. In fact, we have quadratic and quadratic. Moreover, you see the coefficient of quadratic, because if you expand this, then you get yz, xz and xy term. Of course, you can manage to do it, but there is a very beautiful solutions. And hint is the theory which I discussed in the beginning. Anyone who can relate? Okay, nice. Let me solve this. This solution is totally based on observation. You can see first we have 2, 3, 3, 1 coefficient and 2, 1. It means the coefficient is 1, 2, 3. Right? And clearly we can see other vector as x, y, g. So now we have to do something with 1, 2, 3 and x, y, g. We have two choices. So let's say define, if I define a as 1, 2, 3 and some x vector as x, y, g. So in this case, so let's say if I define a is 1, 2, 3 and some b vector as x, y, g. Of course, b is variable, is fixed, right? I should not use this notation, but okay, fine. So now clearly a dot b is going to give you x plus 2y plus 3z, and that's nowhere in the question, neither in the options, right? Okay, so can you think like 3y minus 2z, 3y minus 2z, okay, 3x minus z, so it's like 3y minus 2z is there, right? 3x minus z and 2x minus, oh, something kind of cross behavior, kind of Soule's formula. Well, it feels like cross product. And the question is then, what you can see is this expression is nothing but, if I take a cross b, it's gonna give me I, j, k, 1, 2, 3, x, y, z, and that will give me I times 2z minus 3y minus j times z minus 3x plus k times y minus 2x. And if I take magnitude of a cross b, it will be less than equals mod of a into mod of b. Magnitude of a cross b is our question, less than equals mod of a, x square plus y square plus z square, root, not forget root, and mod of b, which is 9 plus 4 plus 1 is 14. So magnitude of question. X square plus y square plus z square is 1. So the answer is 40. I hope you must have enjoyed this. Okay, this solution. Now some of you might tell like the set S represents a sphere centered at origin. So it's basically the locus of all point whose distance from 0, 0, 0. We can treat it as x minus 0, y minus 0, z minus 0 whole square. It's like a grandfather version of circle, 3D version I mean. And based on that you have to minimum and maximize this. Now the problem is unfortunately you can't visualize this, like there is not a very strong geometrical manipulations or representation of this expression. So it was not a good idea to go geometrically. If instead of this, if someone would have asked x plus y plus let's say 5z maximum minimum value or range, then this represents plane. So I could have taken this equals let's say lambda, depending upon lambda it will be different planes. Okay, so these are like lambda constant, maybe lambda 0.2, lambda 0.3. So isoplanes behavior, parallel set of parallel planes. Okay, now for minimum and maximum value it must be a tangential case. Okay, that you can clearly see, because for any point on this plane there will be same lambda for whether I'm taking this point xyz or this point xyz or this or this. So for all the points on the plane will have same lambda. Of course a plane will intersect a sphere only at 2 points here, because it's not a solid sphere, right? So don't confuse like there will be so many points which will give the same lambda. Only 2 points will give the same lambda. But as you know, according to the y-intercept of plane will be maximum, which means lambda physically represents the z value, maybe when x is 0 and y is 0. Okay, so that will be maximum when it is a tangential case. So we'll get minimum and maximum in the tangential situation. Okay, so when you can interpret the things geometrically, it will be quite easier to manipulate. If you cannot interpret, then you must resort to some other technique. Since the syllabus of JEE Advanced is limited to 2 and 3 dimensions, so the only problem that they can ask from Cauchy Swartz inequality is the application of vectors. So either A dot B or A cross B. Rest all inequality problem, whether it is associated with coordinate geometry or calculus, has to be calculus based. It takes a lot of energy to create videos for you after my own work. So I would definitely be happy if you can spread the video.